Hello and welcome to this short session on the smart world of vision. My name's Neil Sandhu. I work for SICK UK and look after all the machine vision solutions that SICK offers in the UK and Ireland. And this session is just a few pieces of information on how we've got to where we are in the machine vision world, the current technology, how it can be made a bit more intelligent by working in collaboration with other devices such as robots and robotic systems, but then also looking at the next step in terms of accessing extra benefits, extra value out of any system by looking at data analysis and how that could be used. So thanks again for coming in to look at this virtual session, and yeah, we'll go through it shortly. So, just a few points on a brief agenda, as you can see. We're just going to look at what's available in today's technology. We're going to look at how we can make it smarter, and then accessing those extra benefits, and then finally where SICK comes in and how what we have to offer here at SICK can help the realization of these extra benefits and values to any vision application, and also working in conjunction with robotics. So, where are we today? Well, let's look at today's technology. We have various types of cameras that perform machine vision tasks. We have to remember that machine vision essentially was born out of wanting to automate human inspection, so manual inspection tasks that can become, let's say, laborious or perhaps even quite difficult and challenging at very fast production speeds, where an automated system can really help in terms of making sure that inspection can be carried out successfully at different points in the production process or life cycle. So we have various types of cameras, from streaming to programmable, smart systems, vision sensors, PC-based systems. So what I'm going to do now is just take you through some of the key differences between some of those systems, some of the terminology that you may have heard before. So, if we start off with vision sensors. Vision sensors, in essence, as the name suggests, is more like a sensor where you simply are having a power supply, be it 24 volts DC in and an output out, a bit like a standard photoelectric sensor, but also with a little bit more intelligence. So here you see that we talk about a simple vision sensor that's got inbuilt optics, lighting, all the processing is done on board, so all it does need to run is power. It's got configuration available in usually in minutes with some software or over a web browser, and so you can pretty much get up and running with a simple vision task in a matter of minutes, and there's not a lot to the hardware in terms of what you need to get up and running. Moving on from vision sensors, we look at smart cameras, so a little bit higher up the chain. Again, simple, ideally designed to be simple to use, again usually with inbuilt optics and lighting. Lighting is obviously very key to machine vision, especially when we talk about 2D vision when we're looking at contrast-based inspections, but I'll come on to that shortly. So again, with smart cameras, as the name suggests, everything is smartly done inside, so the intelligence is inside the device. There's no external processing to be done. It runs standalone as the vision sensors do, but you usually get a higher level of inspection detail in terms of perhaps better resolutions, more accurate vision inspection tools to go to that increased level of detail that you may need from a vision inspection application. Again, usually inbuilt I/O and communications, and usually, as well as the vision sensors, some software that's usually accessible on a PC or even in the web browser can configure the smart camera to do its task in a short amount of time. Then we move on to programmable cameras. Now, programmable cameras typically are programmed from a lower level, so a bit more in terms of the functional aspects are coming from programming from first principles. So, programming languages or code needs to be developed to create the actual functionality that sits on the camera or device. So typically that is done by a developer or a company, a bit like SICK, who I'll come on to what we do later on. And that then, after it's being created and developed, can sit on the device, just as the smart cameras and vision sensors operate, with some inbuilt processing running along, that's running with the tailored piece of software that's been created to perform a potentially specific task or solve a bespoke application. So very similar to smart cameras and vision sensors, but it's just the fact that the software there usually comes from some development because it needs to be specific or tailored to solve a particular task. So the processing is done on board. Again, you can have inbuilt lighting and optics, and you can get up to higher levels of inspection because you can create specific tools, or the developer can create specific tools, usually inbuilt I/O and comms as well. But as you can see there, programming and development does take a longer time because we are creating software specific to a particular task that is not usually created in a short amount of time. However, once created, a user interface could be deployed to complete the final configuration in a matter of minutes. So once the software has been created, it sits on the device, and then the actual user doesn't need to go into that level of code. They just run a graphical user interface and can configure the programmable camera now as a smart camera or even vision sensor in the same look and feel. Then we have streaming cameras. So typically cameras that are generally smaller in size compared to the other devices I've spoken about already, and these typically are just used to acquire the data or images, basically streaming that information to another device, typically a PC, IPC, industrial PC, or integration machine, that then carries out the processing on board that device rather than on board the camera. So these are purely data acquisition type systems, and that further processing done by, let's say for an example, a PC, will obviously handle the next steps in the process in terms of maybe some I/O and communications. Excuse me. Usually these systems, when we talk about streaming cameras, as you can see there, where the other devices perhaps have inbuilt lighting, you're usually talking about needing external lighting to go with your streaming camera. Again, lighting being quite a critical part of any system to make sure you've got a repeatable environment, to make sure you're getting a repeatable image from your vision system, which is paramount importance to make sure you have a successful vision install. And of course, when you have these systems set up with streaming cameras, the level of inspection, again, the potential goes up, because you can use typically, just like the programmable cameras, you could have some developed software sitting on the PC doing the processing. You could be using one of the many commercially available vision libraries that are out there that can have some high levels of inspection detail. So typically higher levels of inspection, higher speeds, or multiple cameras, if you have an application that needs multiple cameras to take images of a wide area or different parts of an inspection process, then that they really lend themselves to this streaming camera to PC processing type system. And of course, in an industrial PC, usually is used in conjunction with the streaming cameras to handle all the processing. Just a brief section on the difference between 2D and 3D. You may have heard the terminology. Typically 2D is, we're talking about contrast. As you can see here with this box, you can see the lid of the box, the print on the box, and of course if we look inside the box, we can see that we have, in this case, biscuits stacked 4 stacks, which is great, and you can see that everything's in there apparently. But then we look at 3D, Okay, so the same images, but we've imaged them with a 3D camera. We're talking about the height data. So it's height data that's the important thing when it comes to 3D. So we don't see the prints, but we can see any sort of variation if the lid's not on properly because of the height change. But also, quite importantly, if we look at the stack of the biscuits in the 2D image compared to the 3D image, where we're basing on the height information, we can see one stack is actually shorter, which perhaps wasn't as easy to tell with a 2D image, because the 3D image gives us the height data. So that's the key difference here. We're talking about contrast data that comes with a 2D image, and 3D images usually give us the height information. So it's just a simple guideline as to when to think about using 2D or 3D. Now let's look at the robots, because nowadays they're becoming more and more prominent within all sorts of different industries. I mean, typically, as you see from the large picture here, when we talk about industrial robots, the car manufacturing processes and plants have been using industrial robots for many, many years successfully all around the world, and a lot of the industrialization of robotics has come from the usage of robots within that area to come into more mainstream factory automation examples in the food and beverage, pharmaceutical in world consumer, fast-moving consumer goods. You can see here. So the two main areas of robotics that we see nowadays are this industrial end and the collaborative end, which is coming up quite a lot now, with a lot of different companies being able to offer a collaborative robot where there's more human interaction with the robots, and emphasis on the assistance that these can give in any process. And typically we have a number of different types of robots. Some of you may have seen these before, where we have the SCARA based robots, so typically the smaller types of applications where they're mostly moving in X and Y, and the rigidity in the Z axis for the heights. Over here we have the articulated arm, typically, that has a number of rotary joints that could move in different axes, and so you could have the more junctions or joints you have, you could have more degrees of freedom in different axes. We look at the potential of a delta robot, which is typically a three-armed robot that's typically keeping the orientation of the gripper in one plane, and therefore can also operate at quite high speeds in terms of picking and placing. And then another example is the linear type of robot, where we have typically it's like a slide on an XY frame. It's all at right angles. It does make things a lot easier in terms of moving around and looking at the programming side of the movement of this type of robot in terms of its motion. But in terms of what we're talking about here, the smart world of vision, how can we make it smarter? And we have a few challenges that we can mention here, and I'm not going to go through all of the words on this particular slide, but just to say that we talk about potentially looking at robots and making them smarter with robot vision, which is what we're going to talk about. End of arm tooling, so what can we help in terms of in the gripping area in terms of sensing, and of course motor feedback in terms of position, so we can monitor and make sure the accuracy of the robots are considered and made sure they're operating to the levels that are needed. And of course safety. You have to, when we talk about robots nowadays, well, in any case, it's classed as a machine, so any machine that you think about deploying in a factory environment, or in any environment where they could be interacting with people, we have to think about the machinery safety aspects. But yes, in this area, in this session, we're going to be focusing, of course, on machine vision and robot vision. So, in terms of how we can make vision smarter and robots smarter, of course, robots with vision guidance is the key here, in terms of being able to give a robot, for example, the ability with a vision system to see and to know where something is for it to apply the next part of the process, be that picking up to place in some packaging, or to apply the next part of the manufacturing process, be it welding, gluing, etc., or even just to pick up a components to place into a machine for machining, drilling, etc., etc. So we can talk about machine tending by completing parts and looking after the next parts of the process. And typically some more examples here in terms of detecting different types of components, identifying which ones are the next ones to be used in terms of this manufacturing process and placing them in a machine to be cut down or machined to a particular size. Here we see an example where we have an automated picking system. So typically there, with a vision system and a robot, we can look at ways to be able to get a stillage or a container full of a bin full of parts randomly, as you can see there, orientated, just obviously just placed in there after the manufacturing process of these parts, so they could be in any kind of orientation, but the ability with the vision system to actually accurately locate the parts and what position they're in then can give the robot the ability to pick it up correctly and accurately for the next part of the process. And then in the same respect here, in this racking system that you see with these automotive parts, we could be also helping a robot to accurately find the right position that these are lying in, to make sure when they're picked up for the next part of the process, they are extremely well accurately placed. So a few examples, a few more here in terms of how vision potentially can help a robot in different areas, looking at picking from belts and from bowl feeders or from different types of feeding systems, so we can identify and singulate the parts needed, even helping with packaging and placing cases into the right areas for dispatch. And we've mentioned machine tending, where we can look at the actual robot even pressing some buttons on a machine, but also unloading and loading parts into a machine, as well as picking up sort of kitted parts and multiple part detection, identification, and making sure the quality of the parts that it's picking are also up to the levels needed for that next part of the process. So we're all moving and working towards this ideal system where we have, is in this example, a production line of parts, for example, and we have the camera potentially with an inbuilt light and lens, obviously potentially connected to some kind of trigger sensor if needed, an encoder that makes sure if the speed of the belt changes, that the camera can know about it, to make sure that we are monitoring at the right level. And also maybe with a good bad signal, if it's inspecting parts, can even signal an actuator to reject if need be, send information which will come onto to a PLC, which could deal with sending information further up the chain in terms of the monitoring of how the system is working and how the production is going. Of course, we're talking about a robot, so a simple connection over to the robot here, and possibly some sort of user interface. But it's really the key here is this link between the camera and the robot. We're trying to make sure that nowadays is easy to use. It shouldn't be a black art, if you will, to say, oh, I want a camera to talk to a robot to help it pick the right component or part, or find me the right location to work on the next part of the process. And that's what we're talking about here in terms of making things smarter. So if we consider a robot, we consider the robot controller, and we consider a camera. Nowadays, what we can talk about, and I'll come on to the SICK part of this later, is pre-written interfaces between the robot and the camera. So example is the work that vision companies are doing with robot companies to say, you know what, we don't need the customer to do the hard work in terms of writing the interface protocol, if you will, to know that the right information is coming out of the camera and going into the robot to make sure it's receiving everything it needs to in the right way, in the right format, for it to go and do its job. So the work that a lot of vision companies, including SICK, have done with a lot of the robot companies around the world means that this work is already done. And it means that you can simply almost well, in minutes, and there are tutorials on various social media sites that can highlight this. You can set up the connection between a camera and a robot and calibrate it to give all the information for a simple pick and place application in a matter of minutes. And that really is the beauty of where we are now with these pre-written interfaces that have been worked on by many companies around the world. And going on from there, the software that we talked about a bit earlier in terms of could be designed and tailored to sit on a smart device. A bit like, think about our phones. We all have smartphones here from day-to-day use, and we have our own little apps that we use because of what the functionality we want on our phone. Well, what nowadays is available is the same sort of functionality for a camera or for a vision system. As you can see, tailored software has been created and can be created by developers or vision companies to make sure that generic hardware, a bit like a smartphone, is then very simple in terms of which camera you would potentially want to use, and therefore almost the same as downloading the right app will then give you the functionality you need to do the job, in this case maybe working with a robot, and that interface is already pre-done after all the work that's been described here. So there we are, we can select the right app. I want a robotic guidance system for this camera. We simply apply it and connect up the device to the robot, and with the easy to use graphical user interface, even sometimes that actually works on the robot pendant itself. You may not even need to go into the camera's graphical user interface. You can set up a system very easily indeed nowadays. And these graphical user interfaces that I'm talking about are very simple, very Windows kind of driven in terms of just click and drop and drag to select the tools that you want, and you can highlight the type of objects that need to be found, in this case for picking, and it's again a matter of minutes in terms of getting from connecting up to deploying a system that can actually start working for you. So let's talk about these extra benefits that I mentioned earlier in terms of, well, apart from a vision system perhaps doing the job, working with a robot, doing the inspection, telling the robot where the part is so the robot can go and accurately pick it, what are we talking about with the extra benefits? Well, what we're talking about are the data primarily. So let's take this component, which is actually a brake pad. If we were inspecting it, as you can see here with a 3D kind of inspection system, we can see that we could potentially be highlighting some defects. Great, okay, so we're not going to be allowing that maybe to move on in the production process. But what else can, apart from finding out we have a potentially badly manufactured part or there's been an issue, what else can we do? Well, the extra benefits could be which area of the part has been found to be defective, and does this repeat on certain variants that are being produced, certain production lines at certain times of day? Does it point to any sort of root cause in the production process that says we could have a problem? Because if we can highlight that in terms of looking at preventative maintenance and preventative downtime operations, then that's really useful. And what we've found by speaking to a lot of people in industry is to say if they were able to monitor potential issues and perhaps catch them even before they happen, because this could be direct cause of a process that could be monitored, then that would be very useful information and could help identify root causes and save time and save money. Here's another example in terms of portion control. We see a lot in the food industry, and if we have an automated, in this case, slicing system that's producing potentially slices of, in this case, fish, but could be any kind of food product that's supposed to be all the same weight, we could look at the fact that the vision system potentially is analysing the whole piece of food, telling a robot perhaps the slice points, where to cut, but then we could be also looking at the data that this produces, saying and making sure that we are producing the consistent portions. Is there usually is there a tendency perhaps a bit on tolerancing to give too much away, or even on the other side of the coin to not have enough in the actual, let's say, portion that we need to be creating. And if this data is monitored, we could also include if there's any scrap waste from the process, which again could be recycled or could actually be optimized to make sure that the scrap and the waste is minimized. And again, that could be worth a good amount of money and time back to the production areas to say that we're making sure that we're optimizing the data that we see from a vision system or maybe a robot cutting system to make sure that everything is being done at the best levels it can be. And the same here can be said in this example, again more food example here in terms of a biscuit manufacturing, where the heights and the volumes are being monitored, and bearing in mind that the wrapping technology, flow wrapping technology, is used. If the production of these items is slightly larger than normal, even by a small amount, potentially the packing area could receive the same number of items, same number of biscuits, try to pack them, pack won't fit, the pack will then potentially the packing area will have to stop. There could be some waste and downtime in terms of trying to pack too many into a packet. And if we can monitor not only the measurements that are coming out and the data coming out from this process, then perhaps there's something there that could be created into a closed loop monitoring processing system that means that production is accurately monitored in real time to know that we've got slightly larger or slightly smaller items being produced, and therefore the wrapping areas need to adjust accordingly. And this is all data that's available from these systems that help monitor and help quality inspect, but we can actually go a stage further with the data to say we can make sure you get perhaps the right ones, but also in terms of your production, but we can also advise and monitor data to say if there's a cause on why sometimes they are out of the desired levels and limits. And again, I won't go through this one in detail, but similarly on meat products here, where it could be going into an oven, and because of the changing in the thickness, if there's a set time in the oven, we could have incorrectly cooked food items. So that's also something that you could look at with regards to monitoring data from a vision system that could be looking at monitoring this sort of information in terms of volume and shape and size of this kind of food item. So we've talked about data, we've talked about robotics and vision. So what do we mean in terms of accessing this, these extra benefits, this extra value in this data? What do we mean, and where can we see it? Well, we've all probably heard the term Industry 4, and it's probably been around a while now. But what we're talking about is typically looking at, a smarter type of production environment, and looking at how we can be more traceable and monitor what's going on in production processes, for example. And so by looking at some of these subject matters here in terms of looking at remote control and monitoring essentially all the data that potentially could be coming back from the production areas, from vision systems, for example, that to give the opportunity for remote maintenance and online monitoring and predictive maintenance by monitoring certain factors in the process, it gives a higher level, a more top-down view to what's going on in the factory and what's going on in certain areas of the production process, which would be better for everyone in terms of being able to make sure everything's working at an optimal level for a very smooth, efficient process. So typically, if we think about the data chain or the data flow that would need to be sent up to an area where people could view and monitor it, we talk about different levels. So we're talking about, let's say we start at what we call the device levels. Where's the camera sitting in terms of what does it talk to? Well, it talks to a PLC, potentially via some sort of communications device up to the PLC level. But then how do we get information out up to what we call the enterprise or cloud level? Everyone's probably heard of this cloud concept. And how does that then become visible? Well, what we need is a gateway, and gateways can provide the link between the area here and the area up in the cloud, so to speak, which is basically an area that's universally available in the right positions to see the information that's needed, and you can visualize the data very easily to know that you're monitoring the right aspects. So, where can SICK come in? Well, SICK can come in because we've got a lot of the developments that we've spoken about already available. So, for example, the tailored software or the app style of concepting the software, we have something called SICK App Space, and we've already had some developers around the world, including the UK, develop specific tailored software to sit on a generic piece of hardware, a simple camera, to do tasks for robots, guidance, for inspecting prints, for sending data out in terms of how well the process is running. So not only are SICK developing some software based on this app concept, we have developing partner companies in a lot of countries around the world. So we are creating this tailored specific software, working with the robot companies to create easy to use systems, and that's one thing that we're definitely ongoing with. It's an evolving process, but we've already developed some great solutions that are already out there. Typically, there's a few examples based on color inspection, robot guidance, checking information on labels, talking to higher levels, including the cloud. So these kind of apps and these kind of software styles and systems are already out there, and we can help you in terms of if you think you can gain value from using a solution like this. And there are various names here in terms of the sort of apps that have been created in terms of to create specific tailored solutions for industry, for example belt picking and localization for robot guidance with 2D systems as well as 3D. Just a few pictures there of the sorts of systems that we're talking about, from guiding service robots or mobile mini automated mobile vehicles like a AGC, an automated guided car, to an AGV, an automated guided vehicle, as well as looking for the right areas of a pallet to lift up or a dolly position to be moved. Robot picking and placing in large and small components, as you can see here with the feeders or the large car-based components here. We've developed systems that work with most robots and very easy to calibrate and then to initiate a deployment, as well as creating specific solutions for the bin picking and de-racking elements that I spoke about earlier. These are areas of expertise that we have in terms of creating these systems to be able to cope with these typical production pains that we've seen in terms of making sure accurate picking and placing of the parts are carried out, as well as I've said earlier, working with the major robot manufacturers around the world to develop easy to use interfaces. That means that our cameras can either, even in this case, be mounted on the robot itself or be sitting very close by, and the very straightforward interface can actually be run from the robot controller itself. And of course, we talk about accessing the data. Well, the data these days, we talked about a gateway being needed. We do actually have one here at SICK as well. We've created a data gateway that allows data to go from that lower level. We talked about the device to PLC level, and we talked about the cloud and the enterprise level where all the data can be visualized, and we talked about the gateway. Well, we do have a gateway that we can offer alongside our vision solutions. So yes, this is all available from a company like SICK. And typically we talked about the device level to what we call the edge device, and this is the gateway that I spoke about, which then can deliver the data from a lower level up to a higher level. That's why we call it an edge-based system. And these can typically then be creating the monitoring dashboard, if you will, so you can visualize what's going on with a device or process, either remotely on a PC or even up to your mobile phone or tablet. So it can be done for very good remote monitoring. And then up towards, say, this cloud-based environment where there's obviously commercially available spaces, shall we say, that you could then create a lot of remote control monitoring to make sure that the right people can see the right information around the world if need be, to make sure that everything is optimized. So an example would be a factory, in this case a food and beverage plant, where these gateways could be mounted at different positions, different production areas, robotic cells, other inspection areas, and the data could be being sent up to a central monitoring location where everything could be optimized. And also with the ability of these systems, anything that drops below a certain level in terms of production rates, or if there's an issue with a particular line that's producing potentially products or items that are not up to the limits, these can be highlighted and monitored and alerted for within this monitoring kind of system. And typically, as an example here of a demonstration sort of dashboard, as we call it, from our device, here we have the ability to monitor, in this case, flow rates from a sensor. In quality inspection here with a vision system to know that if there's a potential problem with a drive chain, in this case we've simulated a breakage, so we can alert and say a chain snap, so it could be a machine that's down. We look at flow rates from a flow meter, so you can see a lot of data here that's sent up from the device level, as we've called it, all the way up to what we call this cloud-based level, so it can be easily tracked as to what's going on a particular machine or process. So, just to reiterate, the telemetric data collecting unit here that we've just been talking about can be linked to, to the robots, to the vision system, to provide IOs and alarms, to monitor on over tablets or PCs, and you can see there in terms of what you can get out of it in terms of saving image data for production, logging, and remote access for assistance to see what's going on, even to update firmware or software onto devices. By monitoring that data, you can see the hopefully the preventative maintenance aspect in terms of being able to track potential issues and monitor perhaps degradation of certain areas before they reach to a critical point that could lead to downtime, and detecting those failures and analysing all that data up at a higher level. So an example here, we monitored a production in a car plant, looking at various robots and components being placed, etc., and positioning. We can track and keep a good log for the customers here to know that what efficiency they're currently operating on in terms of being able to position everything correctly for the assembly of a particular car. And you can see in this environment there could be many areas here that are linked up to a gateway system that could be sending this data out, and that's really valuable in this case. So the message here is SICK can be a one-stop shop for you for looking at the whole sensor connectivity portfolio, making sure that if you do want to think about your data to analyze and act on it, then that capability is available from SICK with its wide sensor and connectivity portfolio, as well as all the vision and robot guidance solutions that we have. So we like to think at SICK that we make machine vision accessible, and it's something that is not considered now a black art at all. It's something that anyone can really get into and get to grips with, and even get up and running in a matter of minutes. There are some links here that's included on the slides that you will be downloading, and these can take you to various videos on our website, also our website information, and these can then help let you see the specific solutions that are available, but also find out more information about how you can work with us in terms of getting to a solution that you would ideally like to be working with. Thanks very much. It's been a pleasure to talk to you, and thank you for listening. And please contact us for anything else you'd need. Thank you very much.